So today we are learning antiderivatives, which means what function did this derivative come from? So instead of multiplying 3 times 4 and reducing that 3 to a 2, we're going in the opposite direction. So we're seeing where it came from. There are formulas for this, but they're very confusing. I'm going to show you my way. If you need another way, I can record another way. I don't want to confuse you any more than you have to. My program does not have antiderivatives. So what I've done is given you a list of derivatives that you have, examples of functions that you have to find derivatives of, but you're going to find the antiderivative of it. So where it says f of x, you're going to add a little tick mark to your worksheet because what they're giving you is the derivative and you're finding the antiderivative. All right, so here we have to see where this came from. Well, we know that x to the third got reduced from x to the fourth, right? And we know that 4 times something would equal this 4 here. And 4 times what is 4 is 1. So when I go back and find the derivative of x to the fourth, I get 4x to the third. So we're good on that one. On this one, the x would have come from a 3. And here it's a little bit harder. So you say 3 times what equals 2. And then you just divide by 3. So you have a 2/3 here. And what is 3 times 2/3? 2. And then that would have been reduced to a 2. And here we would have had a 2 here. And 2 times what equals 1. So that's 1/2. And you just leave the signs in the problem. Now, the plain number is easy because it came from a 4x, because 1 times 4 is 4. Now, in every function, in some functions, we have a constant. But when you'd find the derivative, the constant was going away, if you remember yesterday. So we don't know what that constant was, but we know it went away, and we're going to put a C there for constant. All of your answers should have a plus C at the end. If they don't, it's technically wrong. Now in this problem, it's the same thing. They're giving you the derivative, and you have to find the function that it came from. And just like we said before, that x to the fourth came from an x to the 5, because yesterday we reduced them, and now we're going bigger. So we have to say 5 times what equals 6, so it's 6/5. And you're going to see a pattern here in a minute. I mean, you'll see what you're doing each time. So then the x to the fourth, that came from x to the fourth, so 4 times what equals 2, and that would be 1/2. And then plus, and you have an x to the 3. 3 times what equals 5, and that would be 5/3. And then you have an x squared. 2 times what equals 6, and that would be a 3. And then this would be a 3x plus c. So let's say I get my answer and I say to myself, I don't know if that's right. Well, just find the derivative of this and see if you end up where you started. So here you end up with 6x to the fourth when you do that one. 4 times negative 1/2 is negative 2x cubed when you do that one. And then you do 5x squared and minus 6x plus 3. So it ended up where it was. So your answer is correct. We're going to use antiderivatives to find integrals, which is how you find the area under the curve. And that's why you need to learn this pretty well. If you need more examples, let me know.